Thank you all for joining us this morning, and thank you so much for having me here. Oh my gosh, I loved your presentation. So it's always lovely to hear all the great work that a lot of different individuals, groups, entities are doing to help solve some of our largest problems. And, you know, one of the things, the other one, that's what you're telling me. Sorry. I'm going to hide those then. Cool beans. Thank you so much. All right, cool beans. So why am I saying solve for H? And it's a little bit cheeky. You know, how do we go from, just solving for X, optimizing these AI solutions, to actually implementing towards some of humankind's global challenges? So that's where the H comes in. And one way that a lot of groups think of this, and one way that's actually a little bit easy to sort of, because one of the questions that I often get asked is like, is this project an AI for social good type of application? And I hate being the judge of like, you are good, you are not good. And if you are not an AI for good program, that doesn't mean you are a bad program. It just means that it's not necessarily working towards one of these goals. So these are the 17 United Nations Sustainable Development Goals, and they've been around for about 4 years or so, and the UN came together with a lot of different experts, and they tried to figure out, okay, well, what are some of the large issues that we're seeing out in the world, and what are the different ways that we can move towards fixing these issues, as well as like measuring what's going on. So, for instance, things like goal number 4, quality education. How do we make sure that everybody in the world has the education that they need in order to have jobs going forward? And this is even more pertinent right now in like the as AI is potentially as AI is creating changes in the workforce. How do we make sure that the communities of tomorrow have the right skills that they need? So you can start to measure, okay, well, what is the information that all children are getting, all globally? What are the information that adults are getting? What is the training, et cetera? And start to measure that on a country-by-country basis. And then, one of it goes everywhere from that to making sure that everybody has clean water, has enough food to eat, has a roof over their head, has appropriate work. All of these things that are very necessary for life, as well as for life on Earth. So, life below water. How do we make sure that we're saving our whales, that we are making certain that our reefs are sustainable? How do we make certain that the animals on land are not going extinct? There was a really, concerning piece of news just a few months ago saying that, more species are going to go extinct than at any other time, and it's becoming more rapid than we ever thought it could, for a large different number of reasons. But how do we measure this? How do we look at it? So that's the idea. And one of the things that I think you've seen in Carla's presentation, and that I'd like to reiterate, is that we can have such a huge impact, and the skills that we know, the technology that we're developing, no matter what it is, from being just from having some machine learning background, from having some AI background, from being a project manager, from everything. Everyone can have an impact in so many different ways. There's sort of 3 different verticals, and it's a little easier than 17 different categories. 3 verticals that we often think about, which is healthcare, earth, way too broad, but something having to do with agriculture, disaster response, conservation, climate change. There was a really cool workshop that I would highly recommend going and looking at the proceedings of at ICML just this last week, on how can AI help climate change, some papers. And there was a very star-studded panel, including Joshua Bengio and others on that. Andrew Ng. It was interesting. The room was packed, as you could imagine. And how do we look at the information that we have, the skills that we have, in order to make a difference? And then social impact, also a very broad category, but how do we protect children? How do we protect ourselves? And also for accessibility, how do we help everybody have equal opportunity? So I'll give a little bit of overview of some of the ones that are up here, and then I'll do a deeper dive into a few different programs. But I want to leave the majority of the time today to tell you about some of the ways that we've gone about doing this type of work, what we've seen, and what is the help that's necessary? How can you provide that? And then the opposite, if you have a problem, how do you get the help that you need as well? So a lot of these problems actually take technology as well as algorithms that we often have in-house already. So the first on the top left, is left. I think that's left. Tumor detection. So there's a lot of different examples of this. Basically, if you have a medical scan, you can this is using an image segmentation type of network. So you're able to show the doctor where in this scan might there be a tumor. Where do they need to pay attention to more? This is really important, especially in some areas, like developing areas, don't have enough radiologists. China also does not have enough radiologists, just because that is that type of work isn't something that those individuals are going into. So there's a need for greater care, and this is where AI is being a force multiplier. So somebody who isn't necessarily as trained, a more general practitioner, is able to use the help of AI and say, okay, I should really pay attention to this area of the scan. And then if it seems like something is off, call in somebody else. But, do that first pass themselves. That helps people get the care that they need faster. An example with the agriculture is, we heard a couple of different examples of using AI and specifically object detection for crop health. This is a picture of a farmer in India, and he's using this computer vision recognition type of tool to look at pests in tea plantations. So they're, the main crop is tea versus cassava or cotton, et cetera. And it's the same type of application, different data set, but very large impact because now the farmers are able to say, how much fertilizer do I need? How much pesticide, et cetera? And that's good for them, better for the environment, better for the crops. One of my favorite projects is on the for the National Center for Missing and Exploited Children. I think you can follow me. I'm so directionally challenged this morning. And what we've been doing with them is that NCMEC gets all of these different pings, and this comes from any entity that has an online presence. If there is any suspected child exploitation, child abuse, it's required by law to send that information to NCMEC. So they get a lot, and they get a lot of false alarms because you don't want to miss anything if you are somebody who has an online presence like Google or Facebook or Twitter or any of these large entities. And so NCMEC has to then go through this and say, okay, is there an issue here, or is this potentially benign? And where is it happening? Especially some of the things that we've been working with them is to scrape the dark web and categorize it, because a lot of this type of activity does happen on the dark web. So what do we do there? How do we categorize everything? And then with the dark web, any type of web instance, it's not that hard to mask where you're from, and it's actually getting easier to have, a VPN into somewhere else. So how do we detect where this is happening so that the right individuals can get called in? So there's a whole different variety of tools and techniques, everywhere from natural language processing to computer vision to detect individuals. And sort of estimate the age too, so that's interesting. But yeah, there's a lot of different things. But I wanted to sort of go into 3 different examples, a little bit more in depth, and I go from something that's like really simple to something that is much more complex, to give you an idea of what we can do. So this is a project that is helping to detect if there is clean water in an area. And the existing systems are really bulky, they're hard to use, they're very expensive, and you can't carry them around with you because they're bulky. So what one of our developers has done, his name is Peter Ma, and he built this system, and this is the prototype that's shown. He built it under $500. The new prototype is much smaller and less expensive as well. And what he did was he just trained an object detection model using a CNN, convolutional neural network, using the imagery, and to determine if there are pathogens in the water. So using like an electronic microscope, you're able to start to see some bacteria in the water. And what this does is it provides a good first pass to be able to say, okay, yeah, this water seems healthy. This water does not seem healthy. Or maybe it's uncertain. And that's, if I can leave you with anything, there's, whenever you train an AI model, you should always get some probabilities out of like, is this bacteria, is this not bacteria, or do I have no clue? And then how do I figure out if my algorithm has no clue what to do? So yeah, keep that in mind. I should really add a slide about that on here. Because the AI is not omniscient. It sometimes does not know the answer. And what do we do when it doesn't know the answer? But what Peter did in this case is he built that all in, as well as a simple UI to show, okay, like where was the sample taken and what was the result? So if somebody is going around and looking at all the water that is in an area, and this is maybe it's in, I don't know. I always wanted to say it's in San Francisco, but that might be my bias because I'm in San Francisco. But you can map it out. And then you're able to say, okay, well, where do we need to then do some mitigation issues? And just with this, very simple model, it's like 95% accurate. So it's not perfect, but it's better than what the current is. And that's one of the big questions, too, to ask yourself is like, can AI move the bar in such a way that is helpful as well as, in a way that is substantial enough that it's worth the effort, worth like bringing it into these communities, because you don't want to disrupt people's ways of lives, et cetera, but also, is it better than some existing sort of situation? And this is using, I'm from Intel, so I always have to tell about what is the Intel tech. But what's sort of cool about this is the tech behind it is that like little USB stick off there to the left or right. And what that is our neural compute stick. And these things run about like $100 offline, online, one of those two. And what it is this like little USB stick is specifically designed for computer vision on the edge. So it's very low power, which is why it can be in a USB stick and has everything ingrained in it. And actually one of the cool things that you can play with if you are doing a vision type of project is we've partnered with Google and have like that AIY kit, which is really fun to do. It's like basically a cardboard box that has a camera, the NVIDIA's visual processing unit, chip in it, a Raspberry Pi. So it's everything you need. And I think that runs about $100 too or something. It's low cost, so it's easy to tinker with. And just say, okay, like, how do I do this? There's a lot of tutorials, and does this work for my purpose? So it's cool to look up. And this project has, one of the programs that I'm gonna be talking about a little bit is the Software Innovator Program. It's part of our software developer program. So if this individual reached out and said, I have this idea, and then we helped him get the technology that he needed, the AI expertise, and the support to show these demos, et cetera. And he's been doing brilliantly with the project ever since. A slightly more complex problem is in the conservation space. And this project, a nonprofit called Resolve came up to us and said, we want to help prevent poaching before it happens. A lot of the mechanisms for determining poaching right now might be gunshot detection, or they see the poachers, they notice that there are dead animals in the area. What this does, though, is there are certain routes that poachers often take, whether it's to get from a home village into the parks or within the parks itself. And so Resolve came up with this idea of trail guard. And so you put cameras, motion sensor cameras, on specific places in a park. And what we did with them was embedded, again, this visual processing unit chip, because we're wanting to do some inference on the edge. These motion cameras are super, super noisy. Basically, they're set to trigger on a dime. If an animal goes across them, it goes off. If the leaves blow, it goes off. Or if a potential poacher goes in front of it, it goes off. And what the park rangers were finding out was that 95% of the images that they were getting were what they considered noise. Some of them had animals, but a lot of them were just trees blowing. And only a very, very small minority of them had people that were in them, whether it was a farmer chasing after their cows or a potential poacher. And so what we helped them do is train an object detection model, embed this VPU into the camera, put that model on the camera, and then now they have something where as soon as the picture is taken, object detection is ran, and only the pictures that have people in them are sent to the park rangers. And so now they're getting a lot less false alarms. They're getting, they're getting some still, because we want to make certain that we do catch all the poachers. So tune it so that there are some false alarms and not a lot of missed images. But it's way better. So again, they're able to do their job in a way that is more efficient and have more trust in the system, which is cool, because now they can say, okay, this camera, and they have the positions of all the cameras, this camera detected a poacher, and there are 3 of them, because they get the images. They are armed, they are not armed. So now I know how I need to react and where to go, which is huge. And it's so cool to try to help prevent, this epidemic that's happening, because it's pretty crazy. By the time I finish this talk, there will probably be at least 2 elephants that have been poached during it on average, because it's one every 15 minutes or so, which is huge. Yeah, and there's not too many of them left. All right, so onto a slightly happier topic, and this is, another really interesting element of a group came to us. They're called WhoBox, and they have been doing a lot in robotics space. And what they wanted to do was create a wheelchair that uses facial recognition for somebody who is wheelchair bound. So this actually is really interesting, because we saw from Carla the speech type of recognition and those types of capabilities using facial gesture recognition. Very similar, but now it's saying, okay, how do I want my wheelchair to move? Going forward, to stop, right, left, and whichever gestures are natural to a person. Because somebody that has different disabilities has different, I guess everybody has their own abilities, and somebody that might be able to smile might also not be able to wink or stick out their tongue, but somebody else might be able to. For me, I was testing this out, and we were at a trade show, and the easiest thing for it to recognize for most people is a smile. So they had it if you smile, the wheelchair goes forward. And so when I was testing it out, I smile a lot, and I'm a giggler. So I couldn't get the thing to stop, because I couldn't stop smiling, which was really hazardous. So we don't want that. So it's a lot of, user testing and, tuning it for the individual
as well. So this was a generic thing. Everyone was fine. They had stop mechanisms, but yes, I just love that story too. And the cool thing with this one is, you want everything to run super fast, and you want it to be exceedingly accurate as well as safe. So everything is done on board, and it's actually done on, it's like basically right next to that yellow box, there's this 8-inch square, what we call the Nook, and you see it's this like customizable computer, and it has a lot of different interfaces, so it's good to tinker with. It's really good to have on capabilities where you need a little bit more oomph in computational power. You don't need a screen, but you want something that is somewhat generic and multi-purpose. And then the camera is this 3-dimensional camera. What we found was that a one dimension wasn't a high enough resolution to get all of the different gestures that were out there. And so trained a model, gathered a data set with a very diverse set of individuals with diverse sets of needs to figure out how do we detect all these different gestures. And one of the things that I love is that Hubox is making sure that they do the deployment in a very careful way, so they work with the individuals every time that they are utilized. Okay, so these projects are all fairly different, but they have a lot of different commonalities. What happens is a group or an individual approaches us, or we hear about a potential issue and then start to figure out what are the different ways that technology can potentially help? Is this, the right usage for technology? Or is it, something where you might just be trying to solve the problem in a technological way where, human power is actually necessary? So doing a lot of advising in that type of realm. And then if it is, the case where technology is very beneficial, we help provide different hardware samples, funding whenever we can, software acceleration, or data science expertise. So it's basically like the full stack, because it's never certain exactly like where in a project you might need help, et cetera. And then, the projects last a long different time. And I keep on bumping this up because it takes, it does take a while. Like some of the projects are fairly short of our engagement. Other ones are multiple years. So like the trail guard anti-poaching camera, has been multiple years in the running because that's a lot of different like hardware and software types of integration. And with all of them, there's a lot of hurdles that we face. And when you're working on one of these projects, these are some of the hurdles that you should consider is, how do I get all the right partners together? And partners, I totally agree, is key. And that's for a few different reasons. How do we make sure that this solution is really what's necessary? Is it wanted by the community or just the organization that's trying to help them? Is it something that is going to do more harm than good, potentially? Because sometimes even if you do have like the best interest at heart for something, you could be creating a solution that actually could be harmful. One of my favorite examples as an example of this is that one group approached us and they were trying to get rid of invasive fish species in some water, and they created this underwater robot. And they were like, okay, can you help us with a computer vision application to like automatically recognize these fish? And I was like, okay. And like, cool, because we're gonna build we have this harpoon on our underwater drone thing that will get the fish whenever it recognizes it. And I'm like, hold on. It's like, what you just described is, not necessarily the best thing to go with at the moment, because it's, in essence, a autonomous weapon, which not so cool. So, but they were just like, we really need to help cull these invasive fish species. So,
yeah, how do you have these hard conversations and in a gentle way as well? Because no one wants to be like, oh, yeah, not so good. So that's one thing, fully understanding the problem, and that stems out of getting the right partners together. And for both of these, is having a lot of conversations really helps. And there is a growing and wonderful community around these topics, which is lovely. They're actually just probably less than a month ago was the third instantiation of the United Nations AI for Good Social Summit. And there is, this event 2 days ago, there was a Data for Good exchange in San Francisco. So the more that I look for these types of events, the more of them that are cropping up, and I just love it. And so, reaching out for help, advice, partners, et cetera, I think is getting easier. And knowing if a solution can help. I already talked about this a little bit. And then there's all the logistics. These are, the least, well, some of the times the least fun, but how do we make sure that there are all the legal agreements in place? How do we make sure that there is funding, that there's staffing, that we have that everyone has enough time to see this through? And then data rights. This might be more of like, some of these are potentially more from like a corporate realm, the things that you might see, but it's something too, like where is this data coming from that we need in order for this project to happen? Or do we need to collect it ourselves? And how do we do this in a way that it works in a way that's beneficial for all? Some of the things that can help as well is that there is a lot of open source data and more of it, as well as algorithms. I think that AI machine learning is getting more and more accessible, which is great and something that I highly advocate for and that I think we should all push for more. And this is just a brief snapshot of, yeah, I keep on needing to move that the link up to the top, sorry. But there's this really cool mind map that an individual put together of the data science and AI for good, of a bunch of different efforts in this space. So it's a cool place to go to figure out what different boot camps, events, open data, organizations, et cetera, and so you can play with it. And I'm sorry it's on the bottom because that's harder to get to, but I think all these slides are getting emailed out to everybody. So that's the solution. Just click on the link. Cool. And one of the things I often get asked is like, okay, I am energized. I want to do this now. How can I help? And there are a lot of different volunteer organizations, and there are more that are growing. So I don't think I have a full list of this either. Some of them include Delta Analytics, which is sort of specific for here in the Bay Area. DataKind is an international organization. Data for Democracy is mostly online, but it's also like international. And so all of these different groups help pair you with a nonprofit that needs help, and it needs help now. So hackathons, data dives, et cetera. And they're great ways to get your feet wet or to continue to work in this area. And then, some other groups that run like hackathons, or there's different like competition types of things. Driven Data is basically Kaggle for good, but specifically just socially beneficial challenges, which is really cool. And then, of course, Bayesian Impact and Kaggle Data Science for Good has different challenges too. And there's a lot of organizations in this area, so Partnership for AI, AI for Good Foundation, AI for All, and they're growing too. And one of the questions that was asked in the last session, which I thought was glorious to hear, is like, how do we make sure that we are keeping people's rights in mind? And there are a lot of different considerations for the projects. some of the ethical pillars that are often talked about is human rights, fairness, accountability, privacy, and transparency, and more. There's another really interesting picture that a group at Harvard put together of all the various ethical guidelines and policies, et cetera, mapped to these and other ethical pillars and who is doing what, et cetera. So some of the ones that fill out all the different circles include IEEE. The ACM has some ethical guidelines as well, and there are many, many more of them. So, if you're looking for ways to think about these projects, which you should, going to them is highly, highly encouraged as well. So, I think this is my last slide. Now that you've listened to me for a bit, there's a lot of different ways to get started, and it basically boils down to getting ideas and partners together, your resources, doing your algorithmic development, and then testing and deployment. So if you're looking for more inspiration ideas, we have a number of them on our website. If you're interested in the developer program, if you're an individual or an academic who is looking to partner in a project, I would point you to the developer program. If you're a startup or a company, we have something called the AI Builders program, and that is very much the same but tuned a little bit towards corporations. So I would point you there. And then I put a list together mostly because I needed to get a list for myself of all the various AI ethical toolkits that are out there, because there's a lot of them, and some of them are as simple as a checklist, some of them are very complex and algorithmic, and so it was helpful for me to organize my thoughts in this way, and hopefully it's helpful for others. But yeah, feel free to reach out, and I'll definitely take some questions.